This part of the presentation hopefully will give everybody some insight to how AI is really going to impact businesses on various different levels. And hopefully you guys can start thinking a little bit more critically about your own businesses, your industries, and how artificial intelligence in one industry may actually impact your business without you even really considering that now. So I want to start with the idea of disruptive innovations. And this is something that we've been seeing. It's been leading up to the stage we're at now, where we're seeing so many different industries that are innovating in different ways. I want to start with a quote from one of the thought leaders on technology and artificial intelligence. I think it's really interesting, and try and keep this in mind through the whole presentation. So Sebastian Thrun, he was the founder of the Google X Labs, and those are the guys that created the Google glasses. If you haven't seen that, definitely check it out, like on YouTube. It's pretty amazing what those can do. He said, a lot of things such as planes, phones, and clothes that we see today are old inventions. Some of them were invented over 150 years ago. In the next 50 years, 99% of those things are going to be replaced by innovations that are being developed and researched today. So I think this is really interesting if we think about all the things that we're doing in, across several different industries. So if we think about, the transportation industry, for example, there's been a lot of talk about the Hyperloop system that's being developed. And there's been this evolution in transportation from, the older steam locomotives and trains that have been developed to higher speed electric trains, to bullet trains, to, today where they're talking about building, like a super high speed system that, can go up to 800 miles an hour, for example, and it can get us from LA to San Francisco in 35 minutes. So huge innovations going on in the transportation industry. Aerospace also. Locally here, SpaceX in Hawthorne, they're doing a lot of really amazing things for aerospace. Just recently they launched their Falcon Heavy rocket into space as a test, and one of the things that they're doing that's really amazing is reusable rockets. And that's the biggest hurdle in the space industry, or the biggest cost, is having the ability to have the funds to keep exploring and keep launching systems into space. And they've figured out how to do it by being able to reuse these engines that launch the rocket into space. So the picture on the bottom right there is showing those first stage engines on the Falcon Heavy, so these right here, that are actually coming back and landing themselves, and they're able to be reused. So SpaceX, one of their missions is to make humans interplanetary. And before, that wasn't possible because of how expensive it was. So now, it's something that a lot of people think can actually happen, because they've figured out how to dramatically reduce the cost of space travel. And you get, crazy things like this that you see, that they've launched this Tesla into space just for kind of fun, to show that, what the capabilities are. And this is a direct result of, what we're calling disruptive innovations, being able to do stuff like this. Something a little bit closer to home probably for all of us is innovations that are going on in consumer shopping. So there's all these digital assistants now that everyone's heard of, like Alexa and Google Home and Siri. And those are really making headway into the consumer world now. And if you think about kind of the evolution of shopping, previously, maybe 10, 15 years ago, if you needed to buy laundry detergent, for example, you would have to, get in your car, drive to the store, go to the grocery store, take out your wallet, pay for it, drive home, right? Now, the next step in the consumer shopping experience was not having to necessarily do that, but being able to go to your computer and order it online from Amazon or from any website you want. and have it show up at your door, within a few days.
In a few hours.
Yeah, and that's where we're at now is, now instead of having to even go on your computer, you can just say to your digital assistant, hey, Alexa, order laundry detergent. And since it's connected to your Amazon account, it will automatically bill your credit card, know your shipping preferences, and have it show up, like you said, in a couple hours. And there's also, different IoT items that are coming out, like those Tide buttons, where you don't even have to say to your digital assistant, order something. You can just press the button, and it knows to order laundry detergent because you've pressed that button and it's connected to your digital assistant. And it'll show up, within an hour at your door. So again, these are, huge disruptions in the consumer space. Similarly, so, if you think about how is that possible? How can companies do that, like Amazon? How can they get something to you in 2 hours? It's because they have to innovate on their end also, not just for the consumer. So if you think about, warehouses, companies like Amazon, they're growing so fast and so rapidly, and they get so many orders, they need to figure out how to be able to keep up with the demand. So what you're seeing here are these robotic systems that are within Amazon's warehouse that are designed to make the fulfillment process as efficient as possible. So automotive is another one, and we're going to spend a little bit more time on this. And Mike, you kind of touched on this. So the automotive industry, there's a lot of disruption happening with self-driving cars and autonomous vehicles and everything. And manufacturers are really investing heavily in this. So across all the different manufacturers, so from Mercedes, BMW, Audi, everyone's really putting a lot of money into this. And it's actually interesting. So in order to test autonomous vehicles, the state of California used to mandate that you had to have a human in the car to do the testing just in case something goes wrong.
Right.
But they just announced, I think yesterday or the day before, that now companies can start testing without somebody behind the wheel. Yeah, effective April, I think 3rd or 4th. Right. So now they still have to be able to be controlled, but they can be controlled remotely. So someone has to be able to jump in and control it remotely from a remote location. This idea of self-driving cars, we want to think about what can this really change for us, and we want to try and go much deeper than just at the surface of if you think about, hey, if a manufacturer doesn't start developing these technologies or investing in it, at the surface, yes, those companies are going to probably disappear, not going to be around because they're not investing in this technology. But we want to go deeper than that. We want to look at how self-driving cars are going to affect other industries outside of just automotive, because that's something that may be important for all of us. So when you think about this, what kind of business opportunities can be created, or what's going to change in the business world with AI and self-driving cars? So from just a time standpoint, in the US, we drive about 750 hours a year. It's about 2 hours a day. And if you think about it, if you didn't have to drive, what would you be doing? So you're going to start consuming more media, for example. You're going to be on Facebook more. You're going to be reading more news. You're going to be being more productive as far as work goes, right? So you can maybe have the meeting at a certain time in the morning that's on your commute rather than you waiting till you get to the office, because you don't need to focus as much on driving. So your productivity levels are going to go up. If you think about being on Facebook, you're going to start seeing more ads. So that's going to change the advertising industry, right? Because people are going to be consuming more advertisements, more media. You're going to be using your phone more. You're going to be using your tablet more. So maybe you have to change your data plans. That's going to affect the wireless industry more. People are going to be consuming more data. 2 hours more per day for the majority of the population, that starts adding up. So that's one way to think about it. So on a personal level, that's how it may affect you, self-driving cars. You're going to be able to do more. But if we, there's really this domino effect of artificial intelligence and self-driving cars that go a little bit beyond that too. So if you think about, for example, accidents, right now about 90% of accidents are caused by some kind of human error. So drunk driving, speeding, falling asleep. That's the majority of accidents that we see in the United States. With self-driving cars, that's going to dramatically change that because you're not going to have humans that are causing these errors. So if we see accident rates going down by 90%, think about, for example, the insurance industry.
That's going to affect their revenue.
Absolutely, right? So if there's no more accidents, should you have to pay as much for your insurance?
That's why I said it's going to affect their
Exactly,
revenue.
right? Do you need to worry about the kind of car you have, right? Do you have to pay more?
I am.
Do you have to pay more because you drive, a Range Rover versus a Honda? Because the accident rates are the same, so it's not going to really affect that. Do you think about body shops, right? If there's no more accidents, how's that going to affect body shops? Yeah, because there's not going to have to be repairs anymore. Also, something that's interesting is that the majority of patients that are in the ER, that go to the ER, like the medical industry, they come from auto-related accidents. So, nobody really can predict what's going to happen, but we have some ideas of the industries that it's going to affect. So if you don't need as many doctors in the medical industry or in the ER room, what can they be doing? What could they be putting their attention on instead of being there? Right? So interesting things to think about. Another thing is utilization. So again, staying with the idea of self-driving cars. So right now, I think there was in 2016, there was 236 million registered cars in the US. There's only about a 5 to 10% utilization rate of those cars. So most of the time, they're parked somewhere, not being used, when you're at home, when you're at work. And if you think about autonomous vehicles, imagine if you could sign your car up to be part of an autonomous rideshare program. So when you're not using your car, it can actually go out and make you money because it's doing Uber for you. So that's the direction, and that's kind of the evolution that's happening with autonomous vehicles and self-driving cars. And then kind of a third example that you can think of how autonomous vehicles are going to affect other industries is if you think about, parking, for example. If you don't need as many parking spots on the street or parking structures, how is that going to affect the architecture of how cities are built? So, you can see that innovation is happening through a lot of different industries. And this is an interesting stat that, this looks at companies, the lifespan of companies on the S&P 500. So in the last 15 years, 52% of companies have disappeared. And the lifespan has, dramatically reduced from, back in 1955, from 61 years down to 17 years. So it makes you start thinking, how can you guys as business owners, or how can industries start preparing for all these changes that are coming our way? And this idea of disruption is not necessarily easy to predict. So this is a quote from a major CEO who definitely underestimated some of the disruptions that were happening. So he said, $500. I said that's the most expensive phone in the world. It doesn't appeal to business customers because it doesn't have a keyboard. iPhones will never sell. So another one. So Netflix is not even on the radar screen in terms of competition. So it's not easy to see when it's happening, right? It's always easier to see it in hindsight.
Yeah.
Right? But this is actually, what we feel is happening right now with artificial intelligence, right? It's going to have such a big impact on the economy, on the world, that we're going to start seeing people that didn't necessarily take it seriously that are going to be like Blockbuster and not going to be able to make it. But, it's like Blockbuster would never, he couldn't predict that everything is going to go to streaming, right? He didn't want to invest in that aspect of technology because he didn't necessarily think it was going to be that big. This kind of takes us into a little bit more detail of artificial intelligence and how it's working, and what we can expect. So just for a brief history, we're in what's called kind of the third wave of AI right now. So AI, like Mike mentioned, is not anything necessarily new. So it started back in the 1950s, early 1950s, and the whole idea of AI was started at Dartmouth, at this Dartmouth conference, and a group of scientists got together, and they basically had the assumption that every aspect of learning could be so precisely defined that a machine can be taught how to do it. And that's where everything kind of sparked from, is to be able to teach a machine how to do it. There was these waves of when it was popular, when people were really into it, and when it started dying down. So the first wave, was in the late 70s, and then there was another one kind of in the late 80s too. The reason for the declines have been mainly because of processing power. So there wasn't necessarily enough computing power, memory, to be able to handle or create something that is really meaningful. So it kind of declined, and when they couldn't create stuff, funding started going down. So that's why you saw the declines in AI, and they call them these winters of AI. Yeah. So why now are we seeing so much talk about AI? So that's what we want to talk a little bit about. There's been kind of this perfect storm of events that have happened that allow AI to really be possible. So the first one is advances in internet technology and data. The second one is in processing power and cloud abilities. And the third is in new machine learning algorithms that have allowed artificial intelligence to get to a stage that we're at now. So the first one, everything is becoming digitized now. And that is basically gold for machine learning and artificial intelligence. What AI really thrives on is data. So now we see everything from digital books to all of our personal info. There's all this sensor data. From an enterprise standpoint, there's transactional logs that are happening. So there's all this data that's, has the ability to be analyzed by computer systems. So, just to give you guys a little perspective on the amount of data, there's 48 hours of video that's uploaded to YouTube every single minute across the world. So there's also 2 million tweets per day and 75 million pictures. So all of this information needs to be saved somewhere. So it's a ton of data that companies now have access to. Up until 2000, we were using a little bit less than 12 exabytes of data globally. And it's predicted that by 2020, we're going to be at 35 zettabytes, which you can see the calculation right here, but it's huge. So this is the first aspect of why artificial intelligence is really starting to flourish right now, is all this data that's available. The second is the advancements in cloud computing. So all the companies like Google, Amazon, Sony, everyone's investing in cloud and server technologies to be able to store this data, to be able to have access to it and manipulate it and analyze it very, very rapidly. So before, you had supercomputers that stored all this data, and it was very, very expensive. Now, with the advancements in server technology, you can do this for significantly less than you were in the past. So now that's why there's the rise in all the startups that are using cloud-based technology and artificial intelligence. And the third aspect of why artificial intelligence is really starting to have a presence is the new algorithms and machine learning. So machine learning is really the core technology of artificial intelligence. And in order to understand machine learning, I want to talk a little bit about an experiment that Google did, that they wanted to see if they could train a computer how to recognize what a cat was. And this is a very interesting project, because if you think about it, how do us as humans recognize what different animals are, right? So we're reinforced from very young ages to see, like when we see a dog, our parents, or we see it in a book that it says this is a dog. And every time we see a dog, we get that reinforcement that this is a dog, this is a dog. So that way when we see one, we always know that this is a dog. And that same idea is how Google did their experiment to teach a computer what a cat was. So what they did is they showed basically this computer thousands and thousands of videos and images of cats. And what the system was able to do was to basically pick out very unique features of those images and find the similarities of those images. So after seeing all these different images and all these different videos, it noticed that there were very similar features like the pricked ears, for example, or straight whiskers. And after seeing so many of them, when the people who programmed this DeepMind system asked the computer, what is a cat? It actually came up with this image, and it did it on its own based on learning from all the past examples. So this was, a very interesting experiment that they did in order to teach a computer what something was and have it understand it. So, this is kind of key in understanding the difference between machine learning and something being programmed. So I'm actually going to invite Rich up to talk a little bit about the differences, because this is fundamental in artificial intelligence. Something being programmed to know something versus the ability for it to learn on its own.
All right, thanks, Afshin. Yeah, so programming versus training, there's a huge difference. Another experiment that was done through the DeepMind team was with a system that could play the most complicated game in the world. It's a Chinese game called Go. It's more complicated than chess. I think you heard a while back that Microsoft and the Watson system, they were able to beat chess players. This is much more complicated than that. Chess, if you consider all the moves that are available in chess, you look at possible patterns, 10 to the 120th power of possible patterns that are available in chess. Go, 10 to the 360th power. Much, much more complicated. Typical system then could not do that until we actually had an increase in processing power and the availability of those systems to do it. So now, how does that apply to, how does this complex sort of character recognition apply to technology? So you have complicated systems that can go through digits like cracking a code, like your password. A system, typically, if you have a 26-character alphabet and you put 4 digits into it, it could crack it in 3 seconds. That's why you need to have a long, complicated password to protect your systems. But this is exponential. So the more digits you add, the more difficult it becomes. But also, the more characters you add, the more difficult it becomes. And if you combine all of that, you get the bottom right here, where if you have a 93-character alphabet and you put it, you have just a 10-digit password, it would take a system 10 million years to decode that. So it's really interesting, because what we're looking at is going through huge amounts of data. So we've been talking about data. Afshin's been setting up data and collecting data. This is where the data really comes into play. And just to give you an example of how important this is, NVIDIA, their core system, their core technology was video processors. They're shifting their technology now into being able to drive artificial intelligence systems. And you can see their stock price at the end of 2016 there, it went up just a little bit because of this trend. So this is all showing you that this is real. These changes are actually happening. So how do we apply this to our businesses, to practical enterprises? This is a great example. Analytic, what they did is similar to the Google Cats, but instead of feeding a system a bunch of pictures of cats, they took millions. Well, so there are millions of diagnostic images created every year in the U.S. They took just a small portion of those images and put it into their system and allowed it to run against an actual doctor. And what it was doing was looking at instances of cancer. So it could see from the data that it was given, just images, nobody's sitting there coding anything, is just given images, is able to tell the difference between, yes, this one has cancer, no, this one doesn't have cancer, this one has this particular type of cancer. And it was very, very, very accurate. And this kind of speaks to your concerns about replacing jobs. Well, this isn't going to replace doctors. This is a system that's built to help doctors, because in the end, a human has to be there to make that final decision on whether or not this system is correct, and actually decide what to do after, let's say, this particular type of cancer is detected. So, not replacing, assisting. Also, law enforcement. So, based on past data that law enforcement has collected on certain types of crimes and locations, they have systems that they're starting to test now where they can actually predict where future crimes may occur. So in applying that, they can look at particular times of day and location and have police officers in the vicinity to react faster and help the citizens of the area by reducing crime. So what do these projects have in common? The biggest thing about artificial intelligence is it's really, really dumb. It needs to focus on a very singular, specific task. That's why you don't see Terminators running around thinking for themselves and running amok, because with the X-ray system, it does one thing. It looks for cancer in pictures. With the Go project, it does one thing. It looks for patterns in this game. And in doing that, it does that task very, very, very well, because it goes through an insane amount of data, more data than all the humans in the world combined could possibly go through themselves. So now what we're doing is with these autonomous vehicles, with the Amazon system, is we're combining those simple systems, those basic systems, and when we start putting them together, now we're getting a little bit more complex. I don't want to say thought, but a more complex system. So instead of doing just one thing well, it does many things well. Like with the autonomous car, it chooses the difference between a tree and a person. It sees a stop sign. It stops the car. It knows the speed limit. Those are all separate tasks that it has to be in the system. And it's learning most of that on its own. There isn't a programmer in the back seat coding, this is a tree, this is a person. It has cameras to do that, and has the system to gather that data and process it. So what can it do and what can it not do? Well, I gave you the Terminator example. So what we know as narrow or weak artificial intelligence, it's what we've achieved so far. So it's good at performing singular tasks. It's based on trends and patterns. And it's absolutely not human level intelligence by even a fraction of a percent. But the direction we're going as systems become more complex and processing power improves, we're getting this more general or strong AI, which we will start to equate as something relatively close to human level intelligence, where where a system can understand the reason that that an object is in an environment. It can understand context. But this is incredibly difficult to do. That's the difference, the biggest difference between human intelligence and the sort of artificial intelligence. And think about inventions. A computer's not going to invent the telephone. It's not going to invent a telescope or figure out how to send a document across the country on horseback. It can't think like humans can. And this is a good example of that here. So in this image, an artificial intelligence system, it could identify the faces. And that technology is already here. Department of Homeland Security does that. Facebook does that. It's not new technology. It can even tell if somebody's smiling. So, the guy on the scale is not smiling because he's not in on the joke, but everybody else is. But what it can't do, it can't understand the context. So it doesn't get why everybody's smiling. So how's that going to change our lives, change the way we work? Well, it's already changing things. So, with Goldman Sachs, instead of having 600 traders on the floor, they really only have 2 traders, and they have 300 data scientists. So you're getting a shift in the type of job people are doing. With media, writers, they could really only write about 300 articles a day, whereas you use an AI system to gather information from news feeds and aggregate that, you can get thousands of articles a day. Raven is a law database. So instead of if you're a lawyer, most lawyers do an insane amount of research to build their cases. Well, this is a system that'll do the majority of that research for you. It'll bring up cases that are relevant to the case you're working on. We talked about Google, Amazon. So there's about 11 million. Just Amazon's device, the Alexa, in homes today. 11 million. And they're collecting data. So when you order something, either online or through Alexa or on your mobile device, Amazon's collecting that data and it's figuring out what the next step is going to be. Are you going to be ready to have toilet paper delivered to your house in 2 months because you typically go through it that fast, or detergent, or what have you? So they're just streamlining their business, but it's disrupting everybody else's. Yeah, so all this is leading to this idea of a smart assistant. So your typical enterprise system right now, you still need to monitor it. If it comes across an error, or if it tries to match data for you, it doesn't have that capacity right now. It's just not built into any current systems. But the future is to interact with your computer at work and say, hey, it's not just asking, hey, have that report ready for me by the end of the week. It's the system is saying, hey, I've noticed that you turn in this report at the end of every week. I've done it for you. Just check it out and make sure that I did it correctly. This is real technology that's coming out very, very soon. We've gone through. We've talked to our customers, and the feedback they've given us is this is kind of the breakdown of the tasks that they do on a daily basis. And what we've figured is about 81% of that is data entry of some sort. It's a mundane task. It doesn't take a lot of thought processing to do that. You're not sitting down. You're not making a decision. You're not trying to come up with a new product or idea. You're not trying to translate or communicate something. All you're doing is taking something from point A and putting it in point B. What if we could eliminate that 81%? How much would that free people up to do more of, decision making, brainstorming, communication. You talked about doctors earlier. What's going to happen with the ER doctors? Well, they're going to be able to spend more time with patients. They're not going to be rushing from one patient to the next, potentially making mistakes. So you're going to have a higher level of care. So what are the steps involved in, and we're just about finished here, what are the steps involved in having this sort of virtual assistant be a reality, even in the next 5 years? Well, first we need to automate routine tasks. And this will be what makes it effective. So we'll automate routine tasks. As I mentioned earlier, we'll be able to get suggestions from systems. So that's going to save us time. And we're also going to have virtual assistants that can predict or project. So based on past financial trends or company data about purchasing or losses or anything like that, this is where your analytics come from. So your system can actually feed you analytics so you can have a discussion about what your next moves are going to be as a company. And I just wanted to step back to this feature extraction just to kind of get it in your head that this can be applied to so many different avenues within a company. The one I'm going to focus on here is invoicing. So a lot of our customers, their biggest pain point is data entry for invoices. They deal with tens of thousands of invoices every month, either coming through in their mailbox, fax machine, or increasingly more through email. So what if there is a way to reduce all of that work using some sort of artificial intelligence system? Well, we can do that. We feed the current invoices into the system. You have the data. The system is trained on it, and now it knows the features. It knows where a company name goes. It knows the invoice number. It knows the date and the amount. All the relevant information. It takes that and it puts it in your system. So you don't need somebody sitting there typing. Exactly, human error. That's all we have for today.